Now we've got the function y equals -2 times x plus 1 squared over x plus 3 times x minus 2. For our vertical asymptote, we're setting each of our factors in the denominator equal to 0. So we have vertical asymptotes at x equal to -3 and x equal to 2. So maybe here's -3 and here's x equal to 2. The degree for both of those was odd, so I'm going to put an O above each of those. For our horizontal asymptote, the degree of the numerator is 2. The degree of the denominator, 1 plus 1, is also 2. So this time, our degrees are equal. So when that happens, we're going to take the leading coefficient of the top over the leading coefficient of the bottom. Our leading coefficient in our numerator is -2. The leading coefficient, if we were to put this in standard form here, would be 1. So we have a horizontal asymptote at y equal to -2. For the x-intercept, that's where our numerator is equal to 0. So I've got -2 times x plus 1 squared equal to 0. If I were to divide by 2, I'd still have 0. If I were to take the square root, I'd still have 0, so it leaves me with x plus 1 equal to 0, just worrying about that factor. So we have an x-intercept at -1, 0, if we subtract 1. Then for our y-intercept, we're evaluating at x values of 0. So we have -2, 0 plus 1 is 1, squared is 1, so we have -2 times 1, over 3 times -2. Those -2's can cancel out, and we're left with 0, 1/3, or 0.3333 if you'd like that better. We've got our horizontal asymptote at -2. We have a negative fraction this time because of this -2 in our numerator. So we're going to start below the horizontal asymptote. I'm going to go ahead and plot the x-intercept, which was at -1, 0, and the y-intercept, which is at 0, 1/3. Starting below that horizontal asymptote, hugging those asymptotes. We had an odd degree, so we need to go back up. I need to make sure I go through these points and I get close to those asymptotes. But since at this value of x, which was -1, we had a degree of 2, we're going to bounce off of that point. So I'm going to go through the points that I have, bounce off of it, and then come back up to the other asymptote. I'm not going to get near this horizontal asymptote in this middle section here because I'm bouncing off of it from the degree of 2 for this x-intercept. And then again, we had an odd degree, so I'm going to go down this time and hug those asymptotes. All right, let's look at one more example. Y equals x minus 2 cubed over x squared times x minus 5. For our vertical asymptote, here we're going to have two of them, one of them at x equal to 0, the other at x equal to 5. The degree at x equal to 0 is 2, so we got an even degree there. And then the degree for 5 is 1, so that one's odd. For our horizontal asymptote, the degree of the numerator is 3. The degree of the denominator is also 3. Those are equal. So I'm going to look at my leading coefficients. The leading coefficient of the numerator is 1. The leading coefficient of the denominator is also 1. 1 over 1 is 1. So our horizontal asymptote is at y equal to 1. For the x-intercept, we need our numerator to equal 0. Even though it's cubed, we can just focus on the factor, which is x minus 2. When that's equal to 0, we get an x value of 2. So we have 2, 0, which is around right here. Finally, for the y-intercept, we're evaluating this function where x is 0. That gives me -2 cubed over 0 times -5, which is 0. We cannot divide by 0, so here there are no y-intercepts, which again makes sense because of that x equal to 0 vertical asymptote. This is a positive fraction, so we're starting above our horizontal asymptote, hugging those asymptotes. Then we had an odd degree, so now we're going to start below. We need to make sure that we touch this x-intercept. What was the degree at -2? Our degree here was 3, so we're going to squiggle around that. which means we're going to start below and we're going to end up going up. So we are going to cross this horizontal asymptote again. So we're hugging our asymptote, and then we're going to kind of squiggle through and then make our way back up towards the other vertical asymptote. We are allowed to cross this horizontal one. And then we had an even degree here, so the arrows are going to be right next to each other, hugging both of those asymptotes. Since there was no x-intercept that's to the left of this vertical asymptote, we don't get to cross this horizontal asymptote. That only happens when we've got this x-intercept that we're heading toward. And that's the graph of that function.